from 0. So for instance, when we say the absolute value of 3, we're asking how far is the number 3 away from 0? So if we look on our number line, if 0's here, to get to 3, 1, 2, 3, we have to move 1, 2, 3 spaces from 0. If we were to take the absolute value of -4, how far is -4 from 0? -1, -2, -3, -4. That's 1, 2, 3, 4 blocks from 0. And so you probably remember this when you learned about absolute value, but absolute values are always positive. Because when we talk about distance, we don't talk in negative numbers. So we would never say, I live -3 miles from school. You would always say, I live 3 miles from school. So we always describe distance using a positive number. So when we get into equations, when we say the absolute value of x equals 4, we want to know what numbers are 4 units from 0. So to solve it, if we take a look at our number line, we count in one direction and the other direction to see how many numbers are 4 units from 0. So 4 is 4 units from 0, but so is -4. So there's two possibilities. X could be -4 or x could be +4, because if I were to take the absolute value of either of those numbers, I would get out +4. So to solve absolute value equations, we are going to follow these steps. The first thing we're going to do is we're going to isolate the absolute value. Isolate means get it alone on one side of the equation. Then we're going to write two different equations, one equal to the positive number and one equal to the negative number. And then we're going to solve the two remaining equations separately. So those are going to be our steps when we solve absolute value equations. So let's take a look. Okay, so my first step technically is to isolate the absolute value. But if we look at it, the absolute value is already by itself on the left-hand side. So we can go straight to step 2, which is to make two different equations. The first one is going to be the inside equal to the positive answer. The second one is going to be the inside equal to the negative answer. So 2x plus 1 stays in both cases. It's the 9 that becomes either positive or negative to represent the distance to the right and the distance to the left on the number line. Then we just solve each equation separately. So our first answer is that x could be 4. Our second answer, when we solve the second equation algebraically, is that x is -5. So those two values make sense because if I were to plug 4 into this equation, I would get 2 times 4 plus 1 inside the absolute value. 2 times 4 is 8. 8 plus 1 is 9. The absolute value of 9 is 9. Same thing if I plugged in -5 for x. I'd get the absolute value of 2 times -5 plus 1. 2 times -5 is -10. -10 plus 1 is -9. The absolute value of -9 is +9. So both answers work, and technically we would put the word or. X could be 4 or it could be -5 to make this a true statement. So for this next one, the absolute value is not isolated. It is not by itself. So I need to get rid of this -4, and I need to get rid of this times 3. We never distribute with absolute value. Think of like this as a wall blocking the 3 from being distributed. So the first thing we need to get rid of is this -4 to isolate the red box. So we're going to add 4 to both sides. We're going to get 3 times the absolute value of x is equal to 12 because that got rid of the -4. And then to get rid of the 3, this is multiplying the absolute value. So to isolate the absolute value, I'm going to divide by 3. Now we have x plus 6 isolated equals 4. Once the absolute value is isolated, that's when you can make your two equations. So either x plus 6 is positive 4 or x plus 6 equals negative 4. And if I solve each one separately, I get x is not negative 10, negative 2 for this one, and negative 10 for this one. And I could plug both of those values in for x to make sure that I got 8 both times, which I would. All right, so for this one, first step is to always make sure we isolate the absolute value. I really like putting it in a box. It just helps me visualize that I need to get rid of everything outside of the box. And so to get rid of 1/2, we multiply by the denominator 2. And so that gets rid of that. And now I have the absolute value isolated. Once it's isolated, I make my two equations, and I'm careful to make sure I don't think the absolute value sign is a 1, because I see that happen a lot. So just be really careful there. 1 equal to positive 14 and 1 equal to negative 14. So the first answer when I solve is 4. The second one is going to give me a fraction. That's totally fine. X is negative 16/3. So those are my two answers, and I could plug both of them in, and I would get 7 for both ones. So just like with inequalities and equations, we have some special cases. So the number of solutions an absolute value equation will have, first we need to get the absolute value isolated. So we always get the absolute value isolated first, then we can determine how many solutions there are. So there's going to be 2 solutions if the equation is equal to a positive number. So for example, when we had the absolute value equal to 4, there were 2 possible answers. X was positive 4 and x was negative 4. Both these numbers, when you take the absolute value, equal 4. We're going to get one solution if the absolute value is equal to 0. Because in this case, there is no positive and negative 0, like there was a positive and negative 4. There's just one value, and that's 0, because there is no such thing as negative 0. And then the last possibility is the absolute value equal to a negative. You're never going to take the absolute value of something and have it equal a negative number. It's just not possible. So for this one, we would say no solutions. So if I were to solve for x in this problem, I first need to isolate the absolute value. So I have to get rid of this 7 by subtracting it from both sides to get rid of positive 7, which leaves me with negative absolute value of x plus 5 equals 3. And this is kind of like multiplying by negative 1. So I'm going to divide both sides by negative 1, which isolates the absolute value. But it says absolute value of x plus 5 equals negative 3. There's no number that I could plug in for x that if I got the absolute value would equal negative 3. 2 wouldn't work. Negative 2 wouldn't work because that would give me positive 3. Absolute value of positive 3 is not negative 3. And neither would negative 8. Negative 8 wouldn't work because the absolute value of negative 3 is positive 3. Nothing equals negative 3. So we say that this has no solution, and that's our final answer.